Hi everyone, today I'm going to go through the notes for lesson 2. This is going to be on pages 6 through 8 in your pink unit 1 packet. So as I'm going through the video, please make sure you're taking notes in your packet so you're ready for discussion when we come to class. So for today's lesson, obviously the big idea here is on limits. This is kind of the first big calculus idea that we're going to be focusing on. And really, there's three things that we need to be able to do, or at least be familiar with after watching this video. The first target we have is I can write a limit statement using correct notation that references a given function. So we're going to be able to need to write statements, and the big emphasis here is going to be on correct notation. As we go through calculus, notation is going to be very important so that we're communicating our ideas precisely. So as we're going through, I want you really making note of this notation so we get that down pretty quickly. Our second target is I can estimate a one-sided and or two-sided limit given the graph of a function. So a big idea here is we're going to be estimating. In calculus, typically when we learn an idea, first we're going to learn how to estimate an answer, and then we'll learn techniques for getting the exact answer. So like with limits, we're going to be estimating and we're going to be given a graph. So we're going to be working with graphs primarily today. And then last, I can justify why a limit does not exist at a point using limit statements when necessary. This justify, whoops, I'm sorry about that. Oh my goodness, what did I do? Okay, so being able to justify, there will be times when we have to write out explanations. And again, like with the notation, we're going to be doing that in pretty precise ways. So when we write our explanations, make sure you write those down carefully and understand the parts of those justifications. Okay, so we're going to do a quick recap of what we did in that Desmos activity where we were reviewing piecewise functions. And so the big idea we talked about in the activity was we were looking at these graphs, and each time you'll notice it's asking for f of 2. So if I look at the first graph, f of 2, hopefully we all know by now, this is referencing the x value. So when I look where x is 2, I'm going to go up to my graph, and I can see the corresponding y value is 4. And this is something that you've done a lot, just finding a function value given a graph. For my second graph, I can look again. F of 2, I find where x is 2. Now, if I go up to the function, the important idea here is I can see I have a closed circle and an open circle. The function is only defined at that closed circle. So again, f of 2 is going to be equal to 4. On the last one again, f of 2, I find where x is 2. I'm going to look up to my function value, but now I keep going till I find that closed circle, and the corresponding y value is 4. So the big idea here was that although f of 2 equals 4, for all of the functions shown in those graphs, each of the graphs looks very different. So in the first one, we can see when we get to x equals 2, the line kind of bends. And the second graph, the line is actually broken. And then the third graph, it looks like there's just one kind of point that was removed from that graph. So the idea here when we get into calculus and we start talking about limits, what we're looking for is a better way to describe the behavior of a function near a particular x value. So we're less interested in the actual function value at that point, but when we're talking about limits, we want to know the behavior. So what is the graph doing near the particular x value? So that's going to be the big idea. So from here, we'll get into kind of the formal definition of the limit and then look at some problems, how you might be asked to apply this. So the limit is the y value that a function approaches as x approaches a specific number. So again, we're saying as x approaches a number, what is the function doing? What is that y value that I'm getting closer to? So in other words, it tells us where the function is heading or where it intends to go. So our notation looks like this, and I'm going to write out how we say this. We say the limit of f of x, so that would be our function, the limit of f of x as x approaches c is L. So now there's a few things that I want to make note of here. So obviously this c is the x value that our function is approaching. And then that L is the y value that the function is approaching. So our limit value is always the y value. So I'm going to put a box around here. When we're talking about the limit, that's always a y value. So let's go ahead. Now, when we talk about limits, we're going to go a little deeper here. We have the idea of a one-sided limit. One-sided limit. So we might talk about a left side limit or a right-sided limit. And here's what we mean by that. If I look at my limit notation here, I can see here this little symbol here. It looks like a minus sign. I'm talking about how I would read that is the limit as x approaches 2 from the left. So that minus sign tells me I'm approaching from the left. So here's what we mean. We can think of that like a dotted line here at x equals 2. And obviously this is the left side of 2 and this is the right side. So if I were approaching 2 from the left, it means I'm coming from this side. So now if I look at this, if I follow this line coming along from the left side, and let's see if I can kind of turn on my laser pointer here. If I'm following from the left side here, I can see as x gets closer to 2, y is getting closer and closer to a value of 4. So my limit as x approaches 2 from the left would be 4. Now let's consider the right side limit. Again, here I'll see 2 and I've got a little plus sign. That's saying I'm approaching 2 from the right in this case. So again, my x value that I'm focused on is 2. So I'm going to think about a dotted line here. And you do not have to draw this. I'm just doing it to illustrate here. So now I'm approaching from the right. So it means I'm coming from this direction. So if I look again here, now as I approach from the right, it means I'm following this piece. And as I get closer and closer to 2, the y value now is getting closer and closer to 5 in this case. So this is a great example. The limit is not always going to match the function value. The limit does not concern itself with what the function value is, but rather where is the function headed. All right, so now we've got the concept of one-sided limits. So now we can go back to this idea of a two-sided limit. So a two-sided limit is when we look at both of the one-sided limits. So this notation that we wrote earlier, when you don't see a plus or a minus there with the C, this is the notation for a two-sided limit. And that two-sided limit exists only if the left-hand limit is equal to the right-hand limit. So I'm going to make a note there. It exists only if the left-hand limit is equal to the right hand, or I think I called it right-sided. So it means the same thing. Sometimes you'll hear me say left hand or left side is equal to the right hand limit or the right side limit. So again, we only have a two-sided limit that only exists if the left is equal to the right. So now let's go ahead and take a look at our two scenarios here. When I look at this notation, I notice here that there's no, if I look right here, there's no plus or minus. So this is asking me for a two-sided limit. So I'm going to make a note here. This really wants to know the two-side limit. So that means I have to compare the limit from the left and the limit from the right. So I'm going to make some notation here. I'm going to consider the limit as x approaches 2 from the left of f of x. Notice whenever I write a limit statement, I have to include the reference to the function name there. So the limit as x approaches 2 from the left, and I have to think about the limit as x approaches 2 from the right as well, because I know this two-sided limit only exists if these one-sided are the same. So let's take a look here. As I approach 2 from the left, so I'm coming up this way, as I get closer and closer to the x value of 2, my y value is approaching 3. So my left side limit is 3. On the other hand, now if I come from the right and I'm following this piece of the function, as x approaches 2, I can still see y is getting closer to 3 from that side as well. So in this case, my two-sided limit here would be 3 because both the left and the right side limit is the same. Now again, the actual function value here, it didn't ask, but I'm just going to make a note. The actual function value at f of 2 was 4. Again, the limit does not have to be equal to the function value. It may, but remember that limit is just telling us where that function is headed, regardless of the actual function value at that point. All right, so again, we'll look at scenario 2 here. We're still looking as x approaches 2, and since there's no minus or plus, I know I'm working with a two-sided limit again. So I'm going to think about, again, the limit as x approaches 2 from the left. And I need to look at what's happening as the limit. Actually, let me move this down. I'm going to put this underneath to leave some room. So I'll put it right here. The limit is x approaches 2 from the right. And we're going to take a look at both of those. So as I approach from the left, x is getting closer to 2. I can see my y value there is 4. So my left-sided limit is 4. On the other hand, as I come from here, follow this part, as x gets closer to 2, I can see from there, I'm actually approaching 5. I have a limit of 5. Now, since these two do not exist, that tells me that my two-sided limit does not exist. And we use DNE. So it does not exist. And here's when we said in the targets that we have to justify, here's what that's going to look like. So we're saying this limit does not exist. Our justification is going to say because, and here's where we know by definition, for that to exist, these one-sided limits need to be equal. In this case, the two-sided limit does not exist because our left-sided limit is not equal to our right side limit. And that's our justification. Okay, so those are all the big ideas. We'll go through, probably not all of these, we'll go through a couple of problems here. Now we're going to use a graph to estimate limits. So we'll go through some problems. These are very basic limit problems, and we'll do a select few and then go over any questions on the rest if you have them in class. So let's go ahead and take a look at some of these problems. So the first one I can see, now something really important we're going to have to be careful is to really look and evaluate, am I looking at a one-sided or a two-sided limit? So in number 1, it's asking me the limit as x approaches -4 from the left. I see that symbol right there, and that's telling me that this is a one-sided limit. So I only have to look coming from the left. So let's see what that would look like. If I find -4, and I'm going to come from the left-hand side, then if I trace down as I approach from the left, my y value is getting closer and closer to 0. In number 2, I'm looking at my notation and I notice that I have this plus. That's telling me I'm looking at the limit as x approaches -4, this time from the right-hand side. So again, that's another one-sided limit. So I can go ahead and take a look. Again, I can find -4. This time I'm approaching from the right. So as I get closer and closer to -4, my y value again is approaching 0. So now in number 3, when I look at the notation, it says as x approaches -4, there's no kind of minus or plus sign. So in this case, I have a two-sided limit, which tells me that I have to check both of those one-sided limits. So as I approach -4 from the left, we got an answer of 0. As I approach -4 from the right, I got 0. So that tells me the two-sided limit then is also equal to 0. All right, let's try another one. We'll skip the next row. Let's look, I'm going to skip down a little bit here. Let's look at number 10. So now number 10, in this case, if I'm careful with my notation, I should recognize that this is a two-sided limit. So that means I have to check both the left and the right-hand side as x approaches 1. So I'm going to scroll back up to the graph. Now, here's where we have to be careful. So x is 1 is going to be right here because of my scale here. So as x approaches 1, so I need to check the left-hand side. Oops, sorry about that. So as I come from the left-hand side, I get closer and closer to x being 1. I can see my y value is also approaching 1. If I approach from the right-hand side, as x gets closer to 1, I'm also approaching a y value of 1. So my limit here would be 1. Number 11, let's take a look at this because this is a little bit different. So now we have the limit as x approaches infinity. And we want to know what's going on there. And we haven't really seen this yet, which is why I wanted to talk about it. So if I go back to my graph, if I'm talking about x approaching infinity, I know that's going to be the end behavior way out at the end of the graph. So if we could think of this going on and on out to infinity, we want to think of really what that end behavior would be. Well, given my graph, it looks like if I were to consider, if this were to keep going, it looks like I'm going to be approaching an asymptote at y equals 0. So in that case, the limit as I approach infinity is going to be 0. Whoops. Go back to my drawing here. That would be 0. Now, the next one, I have x approaching negative infinity. So I'm going to go back to my graph, and now I'm thinking about, well, what's happening kind of way at this end? If I could keep going and going and going, well, based on my graph, it looks like I'm never going to tend towards a certain value. It looks like my y value is just going to keep getting bigger and bigger and bigger. So in that case, our limit value is actually not going to be a finite number, but the limit itself will be infinity. Now, I know I skipped a lot of these problems. What I would recommend you do is maybe try these before coming to class. When we start class, we'll go over any questions from the video, we'll do a little warm up, and then you'll have a chance to practice to make sure at this point we're just really good at evaluating these limits given a graph. All right, please make sure you took really good notes, and I will see you back in class. Thank you.